Here's the second example that we're going to be working with today where we've got fractions in our equation and I really don't want to deal with fractions anymore. So I want to get rid of these denominators. How do I do that? So this denominator has a 6, this denominator is a 3, and this denominator is a 3. So I'm going to find the least common multiple of 3 and 6, the smallest number that both numbers go into a whole number of times. So what I'm going to do is I'm going to count by threes. 3, 6, there you go. 6 is my LCM, my least common multiple of 3 and 6, because 3 goes into 6, and 6 obviously goes into 6. So what I'm going to do is I'm going to multiply both sides of this equation by 6. And I've already demonstrated this in my previous example, so this obviously is a little bit more involved. I've got some more terms here, but I can still do the same thing. If what I do to the left side, I also do to the right side, our equation is still balanced and we're good, okay? So I'm going to multiply both sides by 6. What you have to remember to do when you're dealing with multiple terms is that every single term gets multiplied by 6. So we're going to distribute the 6 into every term. So right here, well, this is really simple, right? My 6's cancel there, and I'm left with 5x. Don't forget to multiply 6 times 4. What is that? 24. And then 6 times 2/3, or negative 2/3, I should say. So one of the things that you can do easily is 6 times 2 is 12. 12 divided by 3 is 4. Okay, so that's going to be negative 4. You can also simplify this 6 and this 3 right here. 6 divided by 3 is 2. So now if I'm just multiplying 2 times negative 2, I get negative 4x. And then I can do the same thing over here. 6 times 5/3, well, I can do 6 times 5, which is 30, divided by 3 and get 10. Or I can do 6 divided by 3, I get 2, and then I'm multiplying 2 times 5, which is 10. And then now what do we do at this point? We combine like terms. So I'm going to identify my like terms, the ones that have an x on the end. Those are like terms. So 5x minus 4x is 1x. I'll just put an x here. And then I have a 24 and a 10. When I add those together, I get 34. Equals, on this side, what I do to the left, I have to do to the right. So I'm going to distribute the 6 into every term on the inside of the parentheses over here. And I get 24x plus 18. And now at this point, I need to solve for the value of x. So what do I do? Let's change colors here. If I subtract, at this point, I usually move my variables to the left. I'm actually going to keep it on the right. I'm going to subtract x, or just subtract 1x, and I get 23x plus 18. And now what am I going to do? I'm going to subtract 18 here, and then what do I get? One of the things that I like to do if you're doing kind of quick math is you can take 34 and you can subtract 20 and then add 2. That's like subtracting 18, right? So if I take 34 and I subtract 20, what do I get? I get 14. And then if I add 2 more, I get 16. Just a little mental math that you can do if you want to think of it that way. And then at this point, what am I going to do? I divide by 23, and I get x equals 16/23. And then it can't be simplified, so you would just leave your fraction just like that. I know it seems like a really ugly number, but we're getting used to our answers being these types of numbers. So that's one of the ways that you can get rid of your denominators so that you're not working with fractions anymore in an equation. I hope it was helpful.